Okay, so a big reason that we're using the Screencast-O-Matic and cherry picking through all these Hoyt McDougall videos is because they don't really line up to what we want, the order that we do it in at our school, and also just some of the added things on there, even if it's your own voice, can go a really long way. So right now I'm going to show you how to take a regular tutorial that I've clipped and uploaded, or a different one of your own choosing, and edit it out a little bit even further. So all I've done is I've lined up here the window that the video plays in, and right next to it I've put a Word document just to give me an additional white screen to go along with this one as Edward Berger here fills it in. So what I'm going to do is I'm going to play his video. I can pause it. I can add to it. Right below this point here is a little draw button, and that's what I'll use over here on my Word document most of the time, um, as poor as it may look. Um, you'll get better as time goes on. So here's the beginning of the video, and here's what you can do for your kids, and just say, okay, ready, set, go.
Looking at various ratios of sides of right triangles leads to some of the most important ratios in all of mathematics. In some sense, the ratios that so much of mathematics hinges on. Those are the trigonometric ones. So let's take a look at a right triangle. And notice that, in fact, if I think of the angles as being the capital letters A, B, C, and the lengths of the sides being the lowercase letters. Well, just to remind you, the lowercase letter A is always going to be the side that's opposite the angle capital A, so we can always identify where things are. Sometimes that's going to be important. C, the hypotenuse here, is going to actually be opposite the 90-degree angle, and little b is opposite this angle, capital B. Well, it turns out if we look at the various ratios of sides, they somehow generate important quantities. And we're going to see the importance of that coming up. Let me introduce you to the three basic ratios.
Okay, so here's some information that we give all of our kids that can be very confusing. One thing that I think really helps them is to break it down and show them, hey, this is how we're going to use it. So at this point in time, I pause this video. I'll come over here and I'll click my draw button, and I'll come over to my white space and I'll say, okay, listen, yeah, we're talking about sine, but it's not just opposite over leg over hypotenuse leg. We just want to abbreviate and make it short, something they can, you know, put on their what we sometimes refer to as cheat sheets. The information that you can squeeze into an index card is usually going to be the most important stuff. So there's our sine, and that is our opposite over hypotenuse. Our cosine is our adjacent over the hypotenuse, and tangent is the opposite over adjacent. And all I'm doing is just clicking down, using my finger on my mouse pad to draw that out. If you use a mouse, that can be helpful. If you want to get more advanced, we can uh, utilize the bamboo tablet, but there that is. And it gives an extra visual to your kids that maybe Professor Edward Berger isn't covering or isn't talking about the way that you want him to. So you can add that in, and we can come back over and we can continue to play.
They're called sine, cosine, and tangent. And just to sort of summarize, to sort of show it to you really fast, when I think about sine, I just think about opposite over hypotenuse. That's how I remember it. So what does that mean? If you want to find the sine of an angle, so let's suppose we're taking a look at an angle here. Let's say the angle A right here. If you want to find the sine of the angle A, what you do is you look at the ratio of the opposite leg, that's little a, divided by the hypotenuse, that's C. And so we see A over C.
Here I'd like to come in and draw my arrow because he keeps pointing. He uses his fingers over and over again. But I also think drawing the arrow in for the kids is one of the big helps that gets them over such abstract things such as our trig stuff. So I'll come back to my draw, and I'll draw in the arrow right here. And they can say, oh yeah, right across from angle A, is side A. I'll go ahead and hit play and pick back up.
If you want to find the sine of the angle B, then what you do is you consider the opposite leg of B, which is little b, divided by the hypotenuse. But it's always, for either of these acute angles, the sine of an acute angle is always going to be the opposite divided by the hypotenuse. That's how I remember. That's the little code in my head that actually allows me to remember this. Now the cosine's a little bit different. It's the adjacent divided by the hypotenuse. So for example, the cosine of the angle A, this acute angle, is going to be the adjacent side, which notice is B, divided by the hypotenuse C. So B over C. What would it be for B? The cosine of B would be adjacent over hypotenuse. That would be this adjacent side, which is A, divided by the hypotenuse. So adjacent leg divided by the hypotenuse, it should be A over C, and it is. Excellent.
Another thing that we do quite often is that's as far as we got in class. We only want to deal with sine and cosine so far. So we can remind the kids, hey, listen, we're going to be dealing with sine and cosine, which means that you're going to have a right triangle, and we are going to be dealing with the hypotenuse. So go ahead and identify the right angle, identify your hypotenuse, and you can go ahead and stop the video right there. Not have to worry about telling the students, okay, well, I want you to watch this video, but I want you only to watch it to a certain point. It doesn't give a time frame in the Holt-McDougall windows, unlike when you upload it to the YouTube, you have more control over that. You can also just kind of come over here and grab hold of the arrows and skip ahead and pull back and pull behind if you needed to. If we want to
And finally,
even
what's tangent of B?
just
Oh, B. So
turn
we jump to B.
Professor Edward
Tangent.
Berger's
That's
sound down or even completely off, and he can go through this whole lesson and you can put your voice on there, which goes so far in these flip lessons. Much of the research that I've conducted indicated that teachers who just used videos created by others, and at times these came from not just one other source like Professor Edward Berger, but they came from multiple sources, that can be a tough thing for kids to swallow. So consistency is important, and if you can add your own voice to it, I think that'll go a long way in your quest to create flip lessons. I hope this is helpful.